So, is my voice audible? Okay. So, let us start the session for week 3. The first question is the energy spectral density of convolution of two signals is always equal to product of their individual EST, whether it is true or it is false. Okay. So, as we are talking about here the energy spectral density. So, suppose we have said that two signals. Suppose one of the signal is x1 of t, another two is x2 of t. Then the question says that EST of, if I take convolution of these two signals, then the energy spectral density of this signal, convolution of this signal, will be always equal to product of their individual EST. Suppose this has a frequency domain pattern of x1 of it, and this has x2 of it. So if I take the Fourier transformation of the input signal, what is the input signal? Convolution between x1 of t and x2 of t. So in frequency domain, what signal we will get? It is just a multiplication of x1 of f and x2 of. And then if I want to calculate the energy spectral density of this signal. Energy ESD, just basically write it. If I want to write it, then what I'll get in the spectrum. So basically, from the Parseval's theorem, just take the mod square value. If I want to calculate the mod t with respect to t for this signal, if this is the input, then it will have the energy relationship. It will be like this: dt, it will be df, and these two quantity will be equal. From Parseval's theorem. So that's why convolution of two signals, and then if I want to calculate the energy spectral density, then it is always equal to the product of the individual ESD. So also, if I want to calculate ESD of x1t, what it will be? Minus infinite to infinite. Now individually we want to calculate to check. So for the first one, it is x1t mod square dt, that will be equal to x1f mod square dt. Second one is x2 tt dt. x2f squared df. So if we multiply these two, do a convolution between these, sorry. So basically, if I want to find the statement whether it is true or not, is always equal to the product of the individual ESD. So what is the product of the individual ESDs? x1f, x2f mod square df. So this value is equal to this value. So the statement is true. Convolution of two signals is always equal to the product of their individual ESDs. Anybody has any question?
No, no, sir.
Yeah. Second question. We have to find a correct statement actually. So I'm giving a four statement. First one is ESD of an energy signal can be periodic. And second one, ESD of a power signal can be periodic. Third one is ESD oblique ESD can be negative. So you have to find what is the false statement here. So the first context is about energy signal. So remember that energy signal it is finite time limited. Or it converges at infinite. So what is energy spectral density? So if you have a signal xt square, if you calculate the power energy of a signal from minus infinite to infinite, you say that it will be equal to xi of f df finite to infinite. If xi of f is the ESD. So actually ESD means over this frequency band how the density of the energy is distributed. So suppose this is the ESD comes like this. So it says more of the energy is distributed within this range and then it goes down again. So what is the density? What is the density of energy of the signal over the spectrum? So you can think how much energy is distributed over the frequency domain for this particular signal. Which, or you can think like that, how much frequency component, which frequency component carries how much type of energy density. But it is a continuous parameter, so it is a density. So if this is periodic for energy signal, then how it will look like? It may look like this. And then if you calculate x of f mod square df, or if I take it is the psi f is the actual ESD, it is ESD, or if we can calculate ESD like this, then from minus infinite to infinite, this total value becomes infinite. If ESD is periodic, it does not have finite energy. Right? So if it does not have finite energy, then it's not an energy signal, because energy signals should have a finite energy. This is the statement. But this statement and this statement are completely opposite. So this statement is counterintuitive. So we say it is energy signal, and we are saying it is periodic. ESD can be periodic. So these two things can never happen. This one and ESD can be periodic. These two are opposite. So this is not true. Similarly, for a power signal, PSD calculates what is the power. But we are already talking about power signal. So we assume that the signal is periodic. That's why we have gone to power signal. But again, if power becomes periodic, then the power of the signal will be infinite. If this statement is true, then this says power of the signal is infinite. This is because we are talking about power signal now, not energy signal. And we are talking about PSD. So from this similar intuition, we can say that power of the signal will become infinite. Just like for ESD, it is periodic. For energy signal, it becomes infinite. Energy becomes infinite. Similarly, for a PSD and power signal, this becomes infinite. If we had said that PSD of a energy signal can be periodic, that could have been a more better type of thing. So we are talking about energy, then it comes to power spectral density. So yes, it is periodic actually. Or ESD of a energy signal is periodic. Sorry, PSD of a energy signal is periodic. That type of statement we can take. But it is talking about PSD of a power signal. So power spectral density, if it becomes periodic, then it again happens the same problem. The power becomes infinite for this signal. And also, this statement cannot be true because why? Because ESD and PSD we take mod square value. And this mod square value can never be negative. Or you can intuitively think that ESD or PSD, power or energy, can never be infinite. Sorry, never be negative. Because for a particular frequency, if energy or power is negative, then what is the physical meaning of that? So over any frequency, it cannot be negative, power or energy. That's why ESD or PSD can never be negative. So all of the statements are false. So this is false, this is false, and this is false. All of them are false. Is it clear?
Yes, sir.
Sir, one doubt, sir.
Yes.
Sir, the second statement, for a power signal, the power is finite, right?
For the power signal,
The total power is finite, right? For a power signal.
power is finite.
Okay. So, power is finite. Okay. So
Yes.
the PS should be finite, right?
Yes, PSD should be finite. That's why we are
Finite.
talking about PSD here.
Okay.
But for a power signal, ESD can be periodic.
Periodic. Okay. EST can be periodic. Yes. Okay, sir. Right.
Yes. So this quantity actually suggests what is the distribution over frequency. And this suggests what is the framework. If we are talking about energy, we know it is if it is periodic, then it cannot be an energy signal. If ESD is periodic. I think it's clear for you, right?
Yes. Yes.
Now question number 3. The PSD of an energy signal is always 0. Option A is true. The option B is false. So here will become more clear what ESD and ESD, the differences. So we talk about the framework, that is energy signal. So once we talk about energy signal, in the time domain, we can see that the signal is periodic. Sorry, it's time limited. Is time limited. Or this will be a converging type of sequence. This can be x1t, x2t. So x1t and x2t both are energy signal. Now, if we want to calculate the power spectral density, what will be the power spectral density? So, for that, we have to calculate minus infinite to infinite s of f df. Now, we remember the power of an energy signal signal is equal to 0. So if we calculate this term, the power spectrum, this is PSD, S of F, df, what it will be? It is actually power spectral density over all the frequency. Suppose the PSD is like this. And if we calculate the area under this curve, density, this is the density. So if we calculate the area under this curve, so that will give me total power. So this will give us the total power. Right. But the power of an energy signal is 0. So what it will be? If we calculate this integration, this will be equals to 0. Because the power of an energy signal is 0. So basically if I do the integration from minus infinite to plus infinite over all the frequency regions and we calculate the power by the integration formula of PSD, then it will be equal to 0. So the only option, because now in the previous one we said that PSD cannot be negative for any for any f value. So basically this cannot be a PSD. This cannot be a PSD. So the only way of integrating over of a signal and it becomes 0, it is like it has some positive part and it has some negative part. And this positive value cancels out this negative value. But for PSD, there cannot be any. So the main motto is here. Suppose this is a signal yt, and if we do an integration from, suppose this is 0 to t, and this is t by 2. So if we calculate the integration over 0 to t of y1 of t, and this is a symmetric signal with respect to t by 2, so it is 0. Why? Because the part from 0 to t by 2 and t by 2 to t, these two cancels out each other. But for that, this thing should be negative. It should have negative y-axis values. But for PSD, it cannot be negative. So the term is S of f is always greater than 0. So that means this integration will be equals to 0. So the PSD is not negative. The term PSD is non-negative. But as we are doing the integration over df for a long distance, so as we are calculating the power, the PSD of energy signal is always 0. Is not a true thing. So what I said that, so to become this integration equals to 0, I just missed out. Sorry. So SF should be 0. Otherwise this integration will not be 0, right?
Yes.
Because if SF has some positive part, if we calculate this integration actually, it will be always greater than 0. If SF has some positive values and SF cannot take negative values. So SF should be always 0. So the power spectral density should be 0. So the PSD should be 0, always 0. So this is true. So once more, I'm just going through all the steps. So suppose we are going to calculate PSD. So that is the formula for calculating the power. This is the, what is the power actually? We don't write PSD. We have the power. And then we are calculating the power by integrating over from minus infinite to infinite and df, and it becomes equals to 0. Then we again say that if SF have power of an energy signal is 0, that is the condition. So this should be 0. So again, if SF is, for some part, SF is greater than 0, this integration will not be 0. This cannot be equal to 0 if SF greater than 0. So the only thing possible is SF should be 0, so that power is equals to 0. Because if SF, for some part SF greater than 0, if we want to calculate the SF of df over this particular region, for some region SF should be less than 0, and that is not a possible case. So that is the reason SF should be 0. Okay. Now the next question. We have to calculate the ESD of this signal, rectangular signal of T by Bt. So to do this, the steps are, first we have to take xt, then we have to do a Fourier transformation x of a, and the energy spectral density is actually mod of xf whole square. So the Fourier transformation of rect signal we already discussed in the previous class is T by AT. This is, then from duality we can found that it is actually AT sync FAT. And so from this we can write the ESD should be, just take the square of this signal. So it will be, sorry, so it was actually B. So it will be B squared T squared sync square is FB. So it's nothing, just you calculate the Fourier transformation, find what is the frequency domain representation, and take the mod square value of this frequency domain representation. That's how you can get the ESD. Now let us go to the question number 5. Again, we have given a signal ht, that is actually 2b by so find ESD. Okay. So here we need to use the duality property actually. So if we calculate the Fourier transformation of this signal in mod t, it actually comes 2b by omega square plus b square. So if we use the duality property in the same way, then we can say that if we want to do Fourier transformation, 2b by t square by b square is actually 2 pi e to the power minus p of mod omega. So we got the frequency domain response. This is h of omega. Now ESD will be h of omega's square. 4 square pi square to the power minus 4 square pi square to the power minus 2b mod of omega. So basically you have to use only the duality property here. We have the time domain signals. We went through the frequency domain pattern, and then we have calculated what is the EST by calculating the mod square value. Now the next question. Excuse me. Your voice is actually not audible. Can you type in the chat box?
Yes, sir, I have written, sir.
Okay. Square of 4 where it was actually? Wait a minute. So it was like 2 pi e minus b mod of omega. Right. So we have to take mod square of this. So that is 4 pi square minus e to the power minus 2b mod of omega. Right. So what is your question actually? It's
Yes,
not.
sir, I got it.
Yeah. Now let us go to question number 6. So for the same signal h of t 2b by t square by b square, we have to define where 99% of the total energy is distributed. So for that we have to think, suppose this is the spectrum and mostly the 99% of the energy is distributed within this particular pattern. So this is minus F99 and this is plus F99. So we have to find what is the range. Okay, so basically, I'm not going to solve the whole question, but I'm going to tell you how to do it. So we have to take, suppose this one, instead of minus F99 to plus F99. So it becomes, we already derived it actually in the previous equation, the frequency spectrum. So it actually e to the power minus 4 pi df. And it should be equal to 2 pi by b 1 minus e to the power minus 4 pi b, and this is F99.
Okay.
We do this integration actually. Now we have to find the F99 such that zero point 0.99% of this 2 pi by b is actually becomes 2 pi by b into 1 minus e to the power minus 4 pi bf99. So why this 2 pi by b? Because if we want to calculate the energy of the signal is actually 0 to infinite 8 pi square e to the power minus 4 pi b into f, and we do the integration over df, this will get the value 2 pi by b. So this is the signal energy. And 99% of the signal energy is this term. And again, over this particular frequency band 0 to F99, we calculated what is the actual energy. This is also the energy, 99% energy. And this is also 99% energy. So both these terms should be equal. This term should be equal to this term. So this term should be equal to this term. That is what we have derived. And from here you can calculate what is the F99 value. Simple equation 2 by b just cancels out, and then it comes like 0.99 is equal to 1 minus e to the power minus 4 pi b F99. And from here you have to get a value of F99. That will be like 0.01. Suppose you can just adjust it like this. 1 minus 0.99 is actually e to the power minus 4 pi b F99, or 0.01 is equal to exponential minus 4 pi b F99. From here you just can easily derive that F99 be, you have to take the logarithm here. So if you just take the corresponding values like this, so just write it. It will be 100 for exponential 4 pi b F99. or F99 will be logarithm of 100 by 4 pi b. This sort of values will come. So the main motto was, I'm again telling, we had derived what is the frequency spectrum. From there, we just calculated the energy based on that, so that within 0 to F99, this is the actual 99% energy. For that, we have taken F99 variable here. Then we calculate the energy of the signal based on the ESD. Total energy we have calculated of the signal, that is 2 pi by b, and the 0.99% is multiplying it by 0.99. And we already, and in another way, we have calculated what is the 99% energy here. So this value should be equal to this value. That we have put the equality type of thing, constant. And then we have derived it. And we got the value ln 100 by 4 pi. I think it's clear for everybody. Is it clear for everybody? Or I have to explain more? So in this question, we are going to deal with the rect function again. So we have a signal xt, that is the rect signal. T by at. So this is the energy signal because it is time limited. Now this signal will have a particular region f0 where s of 0 will be equals to 0. The ESD will be 0 at a particular thing. We have to calculate what is that f0. So we have to calculate where the energy becomes 0. In the spectrum. So again, we have to check, we have to convert the signal as we are doing. Actually, take a time domain signal. Then convert it into frequency domain. Then calculate the ESD. And then check the characteristics of the ESD where it is 0. That is the motive. That is what the question says. Have this energy signal, we have to calculate the F0 where S of F0 equal to 0. So for that reason, we take a time domain signal, then we convert it to frequency domain signal, then we calculate what is the ESD, and we have to check where in which F0, at which F0 ESD equals to 0. Okay. So for this purpose, again, we are going to calculate what is the first, the signal we are taking rate T by AT. And we know the Fourier transformation is T sinc of FAT. So S of F will be what? S of F will be like this. There are 8 terms here. A square T square sinc FAT. So to become S of F equals to 0, we have to find sinc F0 AT, at which point it is equal to 0. What is F0? From here we can get F0 is equal to 1 by 8. Because sinc of this one is 0 is when F0 is 1 by 8. And then it again goes like that. Sinc function I'm just writing the next page so that it becomes easy for everyone to understand. So this is the sinc function actually. And now we have taken the mod square term of this. So suppose it becomes like this. And then this negative term also becomes a positive term. This term again similar in this side also. So this is 1 by 80. If it is sinc of AFT. So at 1 by 80, F0 is equal to 1 by 80, it becomes 0. So F0 is 1 by 80. Okay. So anybody has any more question? So this was all for today's session. We'll meet in the next Saturday.
Okay, thank you.
Thank you, sir.